Assalamu alaikum. In this video, we are going to discuss about the concurrency in Golang. So let's begin. For understanding concurrency properly in Golang, we need to understand the following things. First of all, we need to understand coroutine. Coroutine, which is a lightweight thread managed by Go runtime to execute functions concurrently. So this is the main thing of concurrency in Golang. We also need to understand wait group, a synchronization primitive to wait for multiple coroutines to finish executing. We also need to understand channels. Channels are like a communication media between coroutines. Okay. So first of all, what is coroutine? Okay. We will see a code and then discuss. Okay. Here, this is the main function. From here, the execution will start. When the main function begins, a coroutine is created. Let's say we name it as main coroutine. Okay, so a main coroutine is running, and when we use the go keyword, another coroutine will get created, and the function which is written next to this go keyword will get executed in that coroutine. So in this case, first of all, here the main coroutine was executing, and when this go keyword is found, then another coroutine from the main coroutine will get created, and this function will run on that coroutine. Okay, in main coroutine this function will run. So in main coroutine this function is running, and in another coroutine this function is running. Okay, so kind of these two are running in parallel. Okay, when this function runs, it prints numbers from 1 to 5. Okay, here it is printed, and for this function print letters, characters from 1 to E are printed. Okay, now when we run this code, okay, we will see this A1 2 B C 3 like this. So if we don't use this, what will happen? Let's see. Then this function will get executed, and after completing this function, after printing all these 5, this will get executed. But in this case, when we use go keyword, this runs parallelly, so uh, it doesn't wait for print numbers function to get fully executed. Okay, so they kind of run parallelly. Okay, coming back to the slide. So coroutines are lightweight. Coroutines are incredibly lightweight, allowing thousands to run concurrently in the same program. Here, fewer threads are used. It may seem confusing. First of all, what is thread? Let's understand it. Let's say we are using Chrome browser and there are multiple tabs open. For each tab, a process is running. Okay, let's say we are running YouTube video in a particular tab. Okay, so inside this tab, or we can say inside this process, let's see what happens. A video is playing. Okay, there are also other features like we can hit the like button or dislike button. We can also comment. Also we can see the suggested videos. So there are many features. For each feature or for each task, there are there are a thread running. Okay, so there will be multiple threads running inside that process. Okay, now if we consider other programming languages, for each task they execute or they type of use different threads for type for task 1. Let's say they use thread 1, for task 2 they use thread 2, for task n they use thread n, and so on. This configuration or this thread uses is seen in Java, but in Golang there is not a single thread needed for a single task. Like a single thread can handle multiple tasks. Okay, so a single thread can control or can use multiple go routines. So for this reason the uses of thread is fewer in this case, as a single thread can like control multiple tasks or multiple go routines. Okay, so uh, next, it is efficient. Why it is efficient? As it is using fewer threads, so it uses few amount of memory and CPU, memory and other resources. So it is efficient. And if we discuss about the life cycle of coroutines, when we use the go keyword, then a go routine is created. Okay, but it is it may run or may not run. Like it waits for the CPU to get free, and when it gets a free CPU, then it will start running. Okay, the next step is running. Okay, in the code. Okay, we again go to the code. This is the function which starts in a new coroutine. So when it starts, it will execute this course. Okay, while it is executing this course, it is called running state. But sometimes the coroutine can go in blocked states. When it may happen, we will discuss about channel later, but sometimes it waits for input on a channel. It waits for some input which will come through a channel, so it is blocked when it is not getting the input. Okay, again when it tries to access some resource which is locked by other coroutines or like other something which is locked mainly, without unlocking it cannot access those resources, and so it gets blocked. Okay, sometimes it gets blocked because of system call. And finally the exit, when the coroutine is terminated and resources are released, it is said that it has exited. Okay, now let's discuss about the wait group. So we will see an example of wait group. Before that, let's see some functions. There are three functions. One of them, three main functions actually. One of them is add. In this case, we can add a weight on this weight group. So while adding this, we need to specify a number, an integer actually. So we will specify an integer, and this integer will be added to the weight. Okay, done function, when this function is used, the weight will decrease by 1. Okay, and this weight function, watches the weight how. Okay, weight may seem confusing as there are two weight. One is WAIGST and one is WAIT. So let's say we're saying that value. Okay, so it will increase the value, it will decrease the value by 1, and it will look for the value whether it is 0 or not. If the value is 0, then it will stop waiting. If the value is not 0, then it will wait for that value to become 0. Okay, it will wait until the value becomes 0. Let's say we have 4 coroutines, and we added 4 to the value. Okay, so current value is 4. When a coroutine finishes its execution, then we like call this function. So when a coroutine finishes its execution, then the value gets decremented by 1. Let's say out of 4, 3 coroutines have finished their execution, so the value will be, current value will be 1, because 4 minus 3 is 1. Okay, but still the value is not 0, because one coroutine is still executing. Maybe it is in block tested or something else, so it will wait until the this coroutine executes, and this plan function is called one more time. Okay, let's see code examples. Is for wait group. Okay, same example as we seen before, but here wait group is added. Okay, but first of all, we see the problem in this code. Let's say we want to print numbers from 1 to 50. Then let's see what happens. So what happens is only 1 to 5 is has been printed. Okay, let's say we want to print A to Z here. Now see, only 1 to 26 these numbers has been printed, but the rest of the numbers are not printed. This is because these are running parallelly. Okay, fine, but when this function executes and executes properly, and when the function has completed its execution, then the main function also completes its execution. Okay, so we somehow need to wait for this function to complete its execution. Okay, what we can do, maybe we can add sleep here or something, but this is not a good approach. What is the good approach? The good approach is here using this wait group. Okay, so we have added 2 here, so the value will be 2, and this wg wait group dot wait, this will wait for this wait group value to become 0. Okay, so when will this value become 0? We are passing wait group to these functions. Okay, we are passing this wait group and also deferring wait group dot done, we are deferring it. Okay, when we defer it, while this function executes properly and function execution finishes, uh, in that time this function executes wait group dot done. So the execution of this function means that this full function execution has completed. Okay, and it will decrement the value by 1. So when both of these functions get executed properly, then the value of this wait group will become 0. Okay, so when this wait group the value of this wait group becomes 0, then uh, it will stop waiting and the main function will execute properly. Okay, let's run it. Okay, in this case we have seen that uh, everything has got printed, but what will happen if I add only one value here? Let's see. So in this case only 1 till 27 has got printed. It is because in this case the value is 1, and when this function executes properly and calls this function, the value of weight group will become 0, and again this will not wait and the main function will get executed properly, and the rest of the numbers will not get printed. Okay. Okay, another important thing is channel. So channels are mainly used for passing messages between different coroutines. It is strongly typed, which means we need to specify like which values will pass through this channel. Whether it is integer or character or any other value, we need to specify it uh, when declaring the channel. Okay, so when a channel is declared to pass integer values, it cannot pass character or any other values. It is strongly typed. Okay, the channel can be buffered or unbuffered. Buffer channel means we need to specify a size with when declaring the channel. So like when we receive something, we can, let's say the buffer size is 3. When we receive something, we can receive maximum 3 elements, and sorry, not receive maximum 3 elements, but we can keep maximum of 3 elements there. We can receive more than that, but we can keep maximum of 3 elements at a time. Okay, and unbuffered means when the buffer size is 1, so we cannot store more than one data. Like goroutines, channels have directions, three types of directions. One is send only, which is specified like this. It can only send some data. Another channel is receive only. It is specified like this. So chan and then this sign, it will determine that it is a send only channel, and if we use this sign before chan, it will be a receive only channel. Okay, so this channel cannot send anything, this channel can only receive. And another is bidirectional channel. With if we don't specify this sign here or here, then this will be a bidirectional channel. A bidirectional channel can act like send only or receive only, both. Like it can send data and also can receive data at the same time. Okay, let's see an example. Okay, so here a channel uh, is created, and we have said that this channel can only contain integer values. Like we can only pass integer values from this channel using this channel. Two coroutines, producer and consumer, has been used here. Two coroutines has been used here. In first coroutine, the producer function will get executed and in later coroutine, consumer function will get executed, and we are passing this channel. Okay, this producer function it in its parameter there is a send only channel. This function creates 5 random integers, and these integers are passed through this channel. Okay, at the same time as these two are running parallelly in two different coroutines. So in consumer, it is it uh, it uses a receive only channel, and it receives data integer from the channel and prints that. Okay, so if we run, we can see this output. So some random variables, some random integers are created here and passed through this channel, and these values are received from this consumer function. Like we are sending it in one coroutine and receiving it from another coroutine. So we are communicating between coroutines through this channel. Okay, thank you.